Ladies and gentlemen, let's go ahead and get started. My name is Loftus Mercer. With me today is Tai Lee. I'm a developer on the LabVIEW team. I work on the block diagram, front panel, compiler. I've been all over for a number of years, 18. Tai is relatively new to the LabVIEW team. But when he joined, he came to us as an already experienced programmer and developer and engineer from other parts of National Instruments. And he joined us in the role of tech lead, which is a formal title at National Instruments. So we have project owners who make sure that we build the right things. And we have engineering managers who make sure that the team is doing all right as people. And then we have the tech leads who make sure that the right things get built right. And it's their job to say, yeah, that works, but that architecture isn't going to be maintainable. Or that's, lovely, but, you haven't really actually covered the requirements that we're going to need next year. These sorts of things. And Tai gave a presentation on how he managed his teams, how he had done tech leading in the past, and what he hoped to see when he was joining the LabVIEW team. And not only did that particular presentation impress me, but his ability to actually make that vision happen over the last several months and his time in LabVIEW, I felt it was the sort of information that was more interesting to a broader audience, specifically to my customers. As you all often ask, well, how does LabVIEW handle these sorts of things, and engineering challenges and actual delivery of software? And Tai gave a pretty good breakdown of how we do it, so I asked him to present. So without further ado, Tai Lee.
Can you hear me?
Maybe a little louder.
Hello.
There we go.
Okay. Let's see. I'm trying to have a little bit of fun today. First, a disclaimer, this is all my stuff. The lawyer made me do it. Everything is fictitious, whatever that means. But everything is true. Okay. I developed this set of slides in 2015 when we saw this TED Talk. It's by some psychology team that they looked at why some people can exercise very easily and some people cannot. And it's amazing. They say, oh, there must be some vision thing. And if you put a sign that says go, okay, and you ask people to look at the sign when they exercise, somehow it's easier. Oh, come on, that's so obvious, right? Keep your eye on the ball, or they came up with keep your eye on the goal. The goal, the sign that says go. So my two reactions. One is, don't we all know that already? Well, it turns out no. And second is, come on, this is just a small part of what makes us successful. What about the rest? Somehow they focus on vision and exercise. That's not it. Because even when we visualize in our minds the goal, this is true. It's not a vision thing. So I developed this set of slides to ramp up my team in Romania. And then people liked it. So what do I mean by success and happiness? I'm totally talking about work, not the stock market, not the real estate stuff. That's some other day. So we are engineers. We are always asked to do the impossible, right? When management asks us, can you do this with this team in this limited amount of time? We say, no, it's impossible. They say, well, do it anyways. Okay. If you ask enough times, we'll do it. But I tell you upfront, it's not possible. And then they wonder at the end, why did you have a schedule slip? I told you it's impossible, right? Okay, that's our job. We're asked to do the impossible. And to the management sometimes, hey, can we slip a little bit? We only lost a few people. I was a success. This is not the picture of success, right? My goal is to build a team that can deliver whatever we are supposed to deliver happily, okay? That's the key. I don't want to lose anybody. So that's the picture of what we are aiming for. On time, deliver the impossible, and the team is happy at the end, and they want to do the next project. Okay, now a little bit of story. This is my story, so I'm going to tell it the way I remember. Many decades ago, I was in junior high in Singapore, and I discovered this thing called daytime soap. Okay. And I want to rush home from school to watch the daytime soap. In those days, there was no streaming, no DVR. Video cassette was just invented and it was outrageously expensive. Right? So if you missed the beginning of the show, you missed the whole thing. Because in those days, they already invented this thing called a cliffhanger. Right? At the end of every episode, it's like some shocking events, and you don't know what happens until the next day. And if you miss the beginning, well, the rest is there's a setup for the next day's shocking event. So if you miss the beginning, you just have to listen to your friends talk about, oh, it was great, it was great. And in those days, to walk home from school, it took me 30 minutes normally. Well, if you take the bus is not reliable, so sometimes you get lucky, sometimes 1 hour later you get home. So to run home, to catch my daytime soap, the beginning, that was my impossible task. 30 minutes to go home, but I have to make it 15 minutes or I miss the beginning. So I tried everything, right? You know, like they tell you, put your head down and walk and work and work and work. You can get, no, it doesn't work. Picture this, right? I have to walk down a long way to this shopping mall, and I have to turn and go uphill to this high rise, and then turn again to go even higher to reach home. So 15 minutes, the solution was obvious. After 1 week of trying, I figured out, in order to get home in 15 minutes, I have to reach the first shopping mall in 5 minutes, and then reach the high rise in another 5 minutes, and then get home in 5 minutes. Right? So the magic solution was this. I just focus on reaching the shopping mall first in 5 minutes. Speed walking. Okay, and then the magic is this. If I reach, I tell myself, if I reach the shopping mall before the 5 minutes and let myself take a break, let the blood come back to the legs, go into the shopping mall to have air conditioning, and then 5 minutes up, I start down the next leg, right? And that, I found I was able to do it in 15 minutes. And I was happy, I got my daytime soap. So in conclusion, the magic is daytime soap. Okay. This is the recipe for achieving any impossible goal. Number one, be truly motivated. Okay? Find your own daytime soap. Decompose an impossible goal into achievable milestones. Your shopping mall and high rise. Target a single milestone at a time. Okay. Measure progress. Celebrate success. Now this is the part that nobody tells you. Celebrate success, and then repeat. Okay. Number one is figure out for your team. They have to be truly motivated. okay, there's a big gap between company vision and develop this feature now, I need it now. It's a huge distance. In the case of FPGA compiler, this is just an example. With NXG, we had to develop the FPGA compiler from scratch. Right? So the company vision, right, is make FPGA easy to use for domain experts. How does that translate down to, today I need this feature now for the engineer on the team. Right, so you break it down to, okay, 1 to 5 year ago is advanced state of the art for specific domains. And you take benchmarks and examples from wireless, motor simulation, PID, and so on. And then we break it down further to say, okay, very short term, 1 to 3 year, our goal is to make FPGA compiler for these specific domains faster and better. And then finally, that translates down to your today's feature. Directly address this set of features that is needed by wireless developer. And therefore, the individual engineers start to see the picture of how today's development fit into this roadmap of the company vision. So make sure the team is truly motivated. Decompose an impossible goal, right, or deliverable into achievable milestones. It's important to not dwell on this impossible goal, okay, because we all get bogged down on thinking there's no way we can do this. Right? Analysis, paralysis. By the time you figure everything out, everyone's defeated. So don't think about it too much. And also, watch out for project that says until we have everything done, we can't show anything. And that's a red flag. Because nobody can measure progress. So there's no motivating on the way to the eventual goal. So a good achievable milestone, right, is a necessary step to the end goal. So no matter what, we have to do it anyway. So and it's easy to visualize. We can visualize success on that milestone. We can demonstrate it, and everyone can visualize it. Because when you can visualize it in your mind, it actually is easy to do. Okay, and of course, allows to measure progress incrementally on every milestone. We achieve it, then the next thing. And then teams usually get bogged down which ones to start on first. It really doesn't matter just because all your milestones are necessary to start on anyone. The FPGA compiler example, the impossible goal was to deliver FPGA support. Okay? This is just an example of single cycle loop. Well, that has a lot of features, a lot of stuff to implement and catch up. The NXG pattern. Where do we even start? Well, so let's not think about that. Let's break it down to little features, little milestones. First, for example, we make a single cycle loop. That was easy, right? Blank single cycle loop, a diagram with a single loop. Oh yeah, we can do that. The next, we had control indicators. The next, we had sub-VI. So when you break it down into a list of features like that, the engineers look at individuals. Oh, that is easy. I can do that in a day. Right? Don't get bogged down on hundreds of these. But don't tell them that. Just say, okay, let's just plan for this month. We're going to do 5 features. And each one, people look at that and say, oh yeah, that's easy. And the team just gets going. So we target the individual single milestone at a time. Let's not worry about what happens next. Okay? Focus the team on achieving current milestones. Right? Everything becomes easier because they can see and they can visualize in their mind the amount of work that's needed, and testing becomes so obvious. You demo it, that we're not done. Everyone can agree whether the feature is done or not done. Tested, tested. Now, some people will criticize this as being very short-sighted. And my answer is no. I think most of the time engineering, 80% of the work is in the design and coming up with a solution, and coding and actual implementing the thing is actually 100%. Okay? And it can be redone, refactored easily, but the design part is the hard work. And a lot of times people get bogged down on overwhelming thinking about design of the whole thing. But if you focus on a very simple milestone, the design becomes very clear. Everyone can easily agree on the best design on this particular little thing. And then the coding part is easy, and we can refactor and redo. And when the milestone is very granular and very visible, right, estimates tend to be very easy. And this is when you have to watch out the engineers all of a sudden give very optimistic estimate. Oh, I can do that a day. Because you need 3 days. This is the thing about objects in the mirror appears closer than actually. Now we can measure the progress easily, right? And it's okay to miss your estimate a little bit on individual ones, but you might monitor issues that require sometimes course correction. Right? And engineers are very easy to manage. When engineers are engineers, they have this behavior that if you measure whatever and you report and you graph it especially and everybody can see it, they automatically improve, no matter what. Okay? So if you measure progress on individual milestones, they always hit it. However, you got to be careful about what you measure, how public you report, right? Unintended consequences. And you got to give the team some safe harbor to fail, because no matter how much you say, it doesn't matter that it matters to them. So in the early 90s, Pacific Bell was measuring, the 411 service. When in the old days, you call up the phone and say, directory assistance, I want to find the telephone number for such and such a business in such and such an address. So they started to measure, okay, customer service. Let's measure how many calls, 411 calls took 30 minutes. That's all they were measuring. But the unintended consequence was, if you call a 411 and you say, that business, they hang it up. They hang up on you because they don't want to be measured as taking over 30 seconds. And the whole population in California was trained to say, okay, the first you have to ask is the town, the business name, and address. So everyone is trained to say 411, Mountain View. Right, because that's what they ask. What city, please? And if you don't know the city, they hang up on you because they don't want to be measured to be over 30 seconds. Even though management keeps stressing, it's not going into their performance or whatever, they were just measuring customer service. That was bad. So be careful what you measure, because engineers will improve those measures, for good or for bad. Okay, celebrate success. We are a bunch of pessimists. Okay, these are actual quotes I pulled out from daily meeting status report. Because the engineers, being engineers, they have this attitude that life is hard and then we will die. And then they will report like, okay, I finished my task. Yeah, and if I don't like it, I have to put in some tags. Then they tease out, wait, are you telling me good news or bad news? Right? So my job as team lead is to at the end of the report say, wait, that's good news, right? And to force him to admit, oh yeah, that's good news, but I'm really sad about it. Okay, so celebrate success is very important. That's the recharge. When I reach my shopping mall, I let myself take a break, let the blood come back to the legs before starting on the next one. So celebrate success is the responsibility of the team lead to say, okay, look, you just did something amazing in the, ahead of schedule. I know there are all kind of hacks, and we all never like, what we implemented the first time. You have time to go back. But this is success. Be happy about it. And peer acknowledgement of your accomplishment is the best reward. Okay? So in daily meetings, the fact that I call somebody did something good, and the fact that their fellow engineers know about that, that is the best reward of them all. Yeah, the bonus is good. So daily Scrum meeting, all these turned out to be, nowadays it's called Agile. And then they have Scrum meetings. And people get hung up on the process, starting to forget why it worked. The process was documenting successful teams' best practices. So daily Scrum meetings that are very, very short are useless. If you want status report, you can do it by email. Scrum meetings are good for reaffirming our motivation, right? Reminding people, hey, this feature is good because we're able to focus our eyes on current milestones. Okay, let's not look around. Let's look at today's milestone. Measure progress and celebrate our successes. And then course correction, unintended consequences, shortcuts, we gotta watch out for them. So that's it. Success is very easy to do, and that's our best practices. How to solve a tough problem? I tell the team, don't worry about it. We all don't know what, when we're given a task at the beginning, we all don't know how we're actually going to solve it. That's the fun of it, right? Tough problems are what gets us to wake up in the morning. First thing to do for a tough problem is let's all agree on what the problem looks like, what the real problem is. Right? Sometimes we write it down. It helps to clarify for everybody what the real problem is. Schedule a flash of brilliance, FOB. I say, okay, this problem is tough. And we don't have to solve it today, but we are going to solve it by 1 month time. And I put it on the calendar. Everyone sees that. That's the deadline. That's not when we begin to solve the problem, but we have to come up with a magic solution by that day. Okay, and then we'll sleep on it. Don't worry about it. Then impromptu brainstorming come up, lunchtime. People are thinking about these problems in the back of their head, and they're seeing the calendar. FOB is coming up. Right. Quick prototypes, validate some assumptions, and many times before thinking about it, and you wake up with a solution. Communicate often. Do not meet. I hate meetings. Okay, there's a very excellent TED talk. No mask, no mindless acceptance syndrome. MAS. Well, automatically when I invite to the meeting, we click accept. Don't do that. Question every meeting you're invited to. We can communicate by putting up chairs together, email, and I thought that's our internal web page, one-on-one teleconference. We communicate Sure, the meetings are bad. Why? Meetings are good for some things, like communicate problems, right? Motivation, team motivation, disseminate our plans. This is what we're going to do, get buy-in and align all our efforts. Review progress, right? We celebrate success, that's good. But it's really bad for brainstorming. It's really bad for design reviews, feedbacks, or making any kind of decisions. Why is that? Engineers, a lot of engineers are introverts, okay? And most meetings degenerate into the loudest voice wins, not necessarily the best ideas, right? And it's always easy to pipe up and say, this is why it's not going to work, right? That's easy. It's harder to say, okay, maybe this idea will work. In a group environment, it's easy to shoot people's ideas down than to foster innovation. And communities never make good decisions. And there's always some data missing to make an informed decision. So anybody can ask, can you go back and study some more about this and that, analysis, paralysis. And most meetings I've been invited to, they are over 10 minutes. Some people just chat. Okay, total waste of time. And unfortunately, people whose ideas got shut down, they always rehash the same things over and over again. Every chance they have, new meetings. So, no meetings. Okay. We should functional things versus optimization, right? Let's not over-engineer. Watch out for over-engineering. Right? Again, we're achieving a milestone, short-term, small-scope feature at a time. Let's not try to engineer something that will do everything for everybody. We need to design things with performance in mind, okay, and then put performance aside. Okay, to say, okay, this on a high level, this should be performant. We gotta watch out for inefficient architecture. But once we do that, we start to say, okay, this work is functional versus optimization. We do functions first, we can defer optimization. We can defer performance. Because we implement functionality, we write tests to validate the functionalities, and then we can tune for performance. Like now you have a set of good tests that make sure when you're refactoring your code or whatever, the functionality still work. Without the good test, you're aiming for optimization, you may screw up correctness. And then setting QOR goals up front. Quality of results. It could be runtime performance, it could be accuracy performance, or whatever. But an arbitrary quality of result goal up front is better than none. Okay. Some example, arbitrary target here. The code generation has to be under 2 minutes, no matter what. It's totally arbitrary. But you will find engineers working late in the night to make sure this benchmark falls under 2 minutes, and once it reaches 2 minutes, it goes. Pick those targets carefully. And another interesting one, the chassis should survive throwing down from the top of the roof. Which roof? Building C. Well, why? It doesn't matter, it's arbitrary. And then they actually reach that, right? If you set arbitrary goals and people will reach it, or they will work very hard to reach it, and then no more. Okay. So arbitrary goals are very good because they allow you to measure progress. Right? You're halfway there, you're 3/4 there, you're there. Okay.
And it's okay to never reach it, but having a goal makes people strive for it. Right? You constantly improve it. And again, engineers, they magically improve whatever you measure. So again, watch out for unintended consequences. I do bonus tasks. Right? This is not a task that when you do it, you get a bonus. This is you get to do this task because you did very well on the last job. So this is a bonus. Right? Interesting things, interesting projects that are strategic, and they always get postponed because it never rises up to today's priority. These are really good for us bonus tasks. We all fight to do it, right? But who get to do it? The people who did well on the last time. Right? This is very motivating to engineers. Again, this is a way to celebrate success. Building quality, right? Many projects fail at the end and say because quality sucks. So you have to build quality in from the beginning, right? Reviews, peer review, design review, code review, test review, and all that. Those are good. And it's again, this is part of sharing, peer acknowledgement of successes, right? Sharing your work to your peers. Right? And when you do good, they know it. You know that you know it, and everyone's happy. Test buddy system is good, so it's a challenge, it's a game. Right? You implement, I try to break your implementation, right? And then we switch roles. Test suite, we have to have good test suite, right? Validate the functionality, but also later on when we come back to optimize for performance, right? And people say, what happens when we have too many tests? Well, that's a good problem to have. We can talk about that when we have too many tests. Right? Typically, we have 9 tests. Okay, so if you do all this, success is easy. Happiness is harder. To be happy, a team needs these 3 things. Right? It's not enough just to do the things that you love, or love the things that you do. Right? You need to have purpose, and you need to have pride. You need to build into your team purpose. How to build purpose? We aim high. Okay? And how to achieve a sense of pride? By achieving the impossible again and again and again. So, finally, yes, life is tough and we all die, but in the meantime, that's it.
So, the talk you just saw, as Tai said, he presented this to the LabVIEW, his small team, and to a few of us that were listening in. And we've tried to promulgate some of these ideas to some of the other tech leads. If you're watching this presentation and you are someone who has a team and you're trying to maintain the quality bar and to motivate engineers and such like this, just taking the list of bullet point items and putting it on a little card next to your monitor, it reminds you as you're just working through the day, hey, have I actually done that checkmark item at some point in the last week or so? How long has it been since I last congratulated a member of my team rather than just dumping the next bug report on them? How long has it been since we actually looked at the 5-year vision and said, hey, look guys, we passed the halfway mark on the 5-year plan. And just checking those things off, you can kind of tune yourself around some of these ideas that Tai has laid out. Nothing he said is particularly revolutionary, but it was the first time I'd ever seen it codified in a single location and then followed through with someone who actually showed that list of stuff was achievable. I'm not actually on Tai's team, but I sit next to it, and I can watch the interaction over the course of months through their stand-ups, and the fact that they don't have meetings and stuff like that, and it really does work. So Are there any questions that you all have? Chris?
So I love this presentation because it talks about how the tech lead relates to developers. Do you have any advice on how the tech lead relates to upper management?
What do we say? We manage expectation up. We inspire down. Right? So, long time ago, somebody taught me quality is what you deliver over expectation, right? So, manage your expectation of upper management is important. That's the manager and tech lead's job is to give safe harbor to your team, right? Bad things don't come past you, and good things go up.
I saw a hand here in the middle.
Yeah, so you discourage the meeting thing, which I wholeheartedly agree. But sometimes, so I work at a cube farm, essentially. So without disrupting people, because that's a lot of the times what I have a problem with, is people that don't say, hey, let's set up a meeting and go into this designated area, which there's a few of them that they get booked real quick. So without doing that, you end up having sidebar conversations, and sometimes it can disrupt all of the people around you who have a solution for that.
I actually encourage crosstalk.
Okay.
Because a lot of times when we're talking about a problem, we're so focused on the problem, somebody overhearing it and say, wait, there's a solution. Somebody already did it, right? You guys are reinventing the wheel. So I do encourage sitting together and open brainstorming. Now, sometimes other teams or whatever gets too distracting. Over the years, I've learned to tune them out. But yes, sometimes we have to take things into a room, especially, safe harbor. This idea when we're talking about some, speculative solution that other people we may want to not let everybody know about it until we have formed better ideas. We go into a room, safe harbor. But crosstalk, overhearing within the team is good.
We don't actually have cue balls on LabVIEW. I've been there for 18 years. When I asked about it early on, the answer I was given by my tech lead was headphones. And honestly, you do turn it out, and the Brownian motion of information has saved us more than once as a team overhears what's going on the other side. So I'm with Ty. The crosstalk is much better than the distraction.
Dr. Mack.
Craig. Oh yeah, another one of our technical leads.
So one of the places that local communication breaks down is when you're dealing with people that don't sit near you. So if you're having to coordinate with people from different areas, is that a time where a meeting is actually perhaps warranted? Or how do you approach that?
When we call meetings, we should have agenda and objectives. At the beginning of the meeting, we say, this is what we're here for. If it's to celebrate success, that's what we're here for. If it is to get everybody on the same page, that's it. And sometimes it is to share information and kickstart brainstorming, and that's it. And if you really have to have a meeting about making decisions, you should be aware of people being introverts in the group, and you should never do what do you think, because the first guy's idea, the second one is like, yeah, what is it? Don't do that. But sometimes meetings are good, but you have to manage it. It's very hard to manage meetings. There are lots of books written on it.
What do you find is the most effective kind of matters and metric to get the most most out of the team without being unintended consequences?
What's the most effective metric to get the most out of your team without unintended consequences?
Depends on what you want to achieve. Right? You got for example, bug count. If you want to reduce bug rate, you show number of bugs, or at least number of high priority bugs, and people really work very hard to get that number down, or at least a trend line there. Whatever you show, try to improve that curve. For example, long time ago we tried burn up or burn down chart. Those are useless because they will engineer the numbers. So today I did magically 3 hours of work to bring it down, or 8 hours today. Okay, so beware what you plot.
I was curious, you spoke a lot about visualizing what you are looking to achieve in the short term. We believe a lot in visual management techniques. I was wondering if you guys do anything like that, and something I think you maybe reconsider a little bit is we'll put milestones out for a whole project. Maybe we should just break that down to the next 5 milestones. So you guys do anything like that?
Yeah, we have visualization things about a big monitor with numbers and plots about bug count, how many days. The rally, the user story things, the agile tools. We have those things, and those are helpful. But in my team, we're not only working on one single milestone. We are working on multiple milestones, and one person or a couple of people may be working on one specific things. It's not just whole team working on a single one. So we do break down things. For example, each month's objectives into multiple objectives, and then how it fit into a 3 months objective, and so on.
Anyone else? Okay.
As an individual contributor inside a team, how could you please suggest to motivate our partners?
So how does an individual contributor motivate their peers?
I believe in lead by examples. Okay, I try never tell my team, anybody in the team, what to do or what not to do, whatever. For example, if I want my team to work harder, I stay late. Even if I have nothing to do, I stay late. And you will find that magically everybody stay late. So lead by example is the best way. I believe that works for co-workers as well. If you would like to change somebody's behavior, you do the same. And peer pressure, right? Without saying anything, people look around and say, oh, I better do the same thing.
When we have people who are inheriting projects that they didn't start, do you have a good way to motivate them to get on board?
Motivation of inherited projects.
Bullet number 1, believe in your project, right? You got to find your motivation for the team. Nobody likes to fix other people's problem. You got to own it somehow, right? You got to say, understanding this thing, fixing other people's problem is a stepping stone to something bigger. This is just a stepping stone. That it's a necessary chore that we put up with. But then we can do great things. Got to have that great things. Without that, it's just a job.
So I've had managers measure hours worked, like timesheets as a major metric for like how well you're doing or how hard you're working, and it really bothers me because I see people putting in hours but not producing lots of work necessarily. So how do you balance hours worked with quality of work?
So these are two. I never want to be a manager. I never consider myself a manager because manager manage projects, right? Spreadsheets, right? Garbage in, garbage out, right? Tech lead's job, technical team lead's job is to make the magic work, right? It's the people, motivation, deliverable. Who cares about number of hours worked? Who cares about lines of code, right? In the old days, we measure lines of code, and the magic number was 17 lines of code per week or whatever. And people are just putting in like crazy indentation, right? So beware of unintended consequences. Now, managers have to do their thing to satisfy their hierarchical requirements, right? We all understand that. But engineer's job is to be successful despite that, right?
I want to play, that's exactly why the three roles are completely different people at National Instruments, and they're never supposed to be one person holding more than one of those titles. Sometimes we'll do it like as a stopgap if someone leaves, but we try to fill them. The project owner, the engineering manager, and the tech lead are three distinct skills with three distinct things. And so a question on, hours worked and that sort of metric, that's going to fall more on the engineering manager side. And that's, are we actually getting effort out of our employees? Are we managing morale of the overall friction of the team? Like this person doesn't like working with that person, that sort of stuff. So it falls, Ty's point is essentially that kind of falls outside of his domain. And if you're not properly siloing those things, one person trying to balance all of those metrics, you will end up measuring the wrong one because you can't really be that person for all three of those roles. That's what we have learned over the years, and we're not alone in the industry with that position. Our model is based on a lot of other companies that have the same divisions. Chris?
So given it as significant resources where you can have those three roles, how would you map those three roles in case where smaller companies don't have those kinds of resources?
Well, do you want to field that, or?
Yeah, I've been in small companies where you wear different hats. Right? You just have to be aware of of those different roles and conflicting requirements, and you turn inward to a team, and I'm a tech lead. You turn outward to the management, and I'm a manager. Right? And sometimes you have to play the role of marketing and I say, this is what customers want, this is what they will pay. It's not challenging, it's not fun, but this is what we have to do, right? Get our paycheck.
Some of you may have seen when I post on the forums, I will often formally state, speaking as LabVIEW R&D, speaking as a G programmer, and that conscious declaration that you are now in a different role, something I picked up from other managers I've had over the years that have had to have that dual split. Formally declaring in your head which one you're currently doing helps a lot with making sure you're not overstepping bounds on one of those. Last question? Anyone else? All right, well, I hope it was helpful. I hope you take something away from it. So enjoy the rest of NIWeek. Thank you.